Bitcoin. You've definitely heard the name, you've seen the crazy headlines, but what is it really? Beyond the hype and the spectacular crashes, there's a pretty revolutionary idea at its core. Today, we're going deep. We're going to use the original 2008 white paper as a roadmap to really understand how this thing actually works, why it was even created, and the massive challenges it's facing. All right, let's get into it. See, to really get Bitcoin, you first have to understand the problem it was designed to fix. For decades, some of the smartest people in computer science were totally stumped by one single question. And it's the entire reason Bitcoin even exists. What is the hardest problem in digital money? So, what is that problem? Well, it all comes down to a really simple idea. I mean, the subtitle here says it all. You can't just attach $1 to an email and send it to someone. Not in the same way you can send a photo. And understanding why is the key to unlocking this whole thing. Just think about it for a second. If I send you a photo, I still have my copy and you have yours. We both have it. That's just how digital stuff works, right? But if I send you $10, I can't also get to keep those same $10. In the world of money, that's not a feature, it's a total disaster. This is what's called the double spending problem. And for a long, long time, there was only one way to stop it. Yeah, for years, the only solution was to have a trusted middleman. A bank, PayPal, Visa, someone in the middle who keeps the one true master list of who owns what. They're the referee. But having to rely on that referee creates its own set of issues, right? You've got fees, you've got censorship, you have to trust them completely. Satoshi Nakamoto's big breakthrough was asking a simple question. What if we could just get rid of that central party entirely? And that's where Satoshi's solution comes in, all laid out in this brilliant 9-page paper from back in 2008. It's this incredibly elegant system that's a mix of cryptography, economics, and a little bit of game theory, all working together to create a system where we can all agree on a shared history of transactions without having to trust anybody. And here's the basic logic. First off, you use something called digital signatures. It's just a bit of clever math to prove you actually own the coins you're trying to send. Okay, easy enough. Step 2, you shout out every single transaction to everyone, and it gets put into a shared public history that anyone can see. That's the blockchain. Third, and this is the really clever part, to stop people from going back and changing that history, you make it incredibly expensive and difficult to add a new page or block of transactions. This is done with a computational puzzle called proof of work. Basically, computers have to burn a ton of real-world energy to win a race to add the next block. Fourth, the whole network just agrees that the longest chain, the one with the most work, the most energy burned to create it, is the official one. So why would anyone do all this work? Well, that's step 5, incentives. You pay these people, the miners, for their honest work with brand new Bitcoin and transaction fees. And finally, the more blocks that get built on top of your transaction, the more secure it becomes. So the whole philosophy here is completely different from a bank. A bank's ledger basically says, trust us, we've got it. Bitcoin's ledger says the exact opposite, don't trust anyone. It is a system built on verification, not trust. You don't have to trust me or a bank or anyone because you or your software can check the rules and the entire history all by yourself. Okay, so this brings us to something you hear about a lot, but a lot of people get wrong, the 51% attack. This is what could happen if a single person or group gets control of more than half of the network's total computing power, that hashing power we talked about. If they can solve those puzzles faster than everyone else combined, they can start to cause some real mischief. But it's so important to understand what they can and, more importantly, cannot do. An attacker with a majority of the power can go back and reverse their own recent payments. They could essentially spend the same coins twice. They could also choose to ignore or censor other people's transactions. But, and this is the critical part, look at what they can't do. They can't just steal your coins from your wallet. They can't change the hard-coded 21 million Bitcoin supply limit. They can't just print new coins for themselves out of thin air. And why not? Because the thousands of other computers on the network, the full nodes, are all independently enforcing the rules. If an attacker tries to submit a block that breaks a rule, like creating fake coins, the rest of the network just rejects it as invalid. So having more power lets you write the most recent history, but it doesn't let you break the laws of physics for the system. So that's the blueprint. But how has this whole experiment actually played out in the real world? Well, from that abstract idea on paper, Bitcoin has had an absolutely wild, chaotic ride. It's a story of insane bubbles, soul-crushing crashes, and somehow, against all the odds, survival. And this timeline here just hits a few of the massive moments. It starts as just an idea in 2008.
Then you have the Mt. Gox exchange collapse in 2014, which was a huge wake-up call. A major internal debate about the protocol gets resolved in 2017. Then the first country, El Salvador, makes it legal tender in 2021. And then, a huge step into the mainstream, the US approves spot ETFs in 2024. Every single one of these events tested the network in a totally new way.
And throughout that entire history, the one constant has been volatility. I mean, we're talking about absolutely stomach-churning drawdowns. Look at this, a 94% crash back in 2011, an 84% crash after the huge 2017 bubble, and even in the most recent cycle, a 77% crash. As our sources point out, even big institutional money coming in hasn't stopped these brutal bear markets. And the repeated collapse of these big exchanges, from Mt. Gox way back when to FTX more recently, really hammered home one of the most vital lessons in this space, summed up perfectly in this phrase. It means that if you let someone else hold your Bitcoin for you on an exchange, you don't really own it. What you own is an IOU from them. This really highlights the critical difference between the Bitcoin protocol itself, which has, by the way, never been hacked, and the often very fragile, very human companies that are built around it. And as Bitcoin just kept surviving these tests, kept not dying, the rest of the world really started to pay attention. Governments and central banks went from basically laughing it off as a toy for nerds to actively trying to figure out what it is and what it means for them. But here's the thing. All that attention hasn't led to any kind of agreement, not even close. Around the world, governments are completely split on what to do about Bitcoin. Is it a threat? Is it an opportunity? Is it property, a currency? Nobody seems to know. You can basically sort the world's reactions into four main buckets. On one extreme, you have the countries that fully embrace it, like El Salvador making it actual legal currency. On the total opposite end, you have those that restrict it, with China's outright ban on pretty much everything being the biggest example. Then you have the US approach, which is to sort of financialize it, to team it by putting it inside regulated wrappers like ETFs. And then there's the biggest group by far, everyone else, who are just continuing to observe from the sidelines, putting some cautious rules in place. So it survived all of that. What could possibly be next? Well, the final and maybe the biggest challenge on the horizon isn't about the economy or politics, it's technological. It's the threat of quantum computing. Now, the quantum threat is a little nuanced. It's not an all-or-nothing thing. A powerful enough quantum computer could theoretically completely break the kind of math Bitcoin uses for digital signatures. That's the part that proves you own your coins, and yeah, a break there would be catastrophic. But the threat to the hashing algorithm, the math used for mining, is actually less severe. A quantum computer could speed it up, making it weaker, but it wouldn't be totally broken. So, is it game over? Well, not so fast. For one thing, the kind of quantum computer you'd need to do this stuff simply doesn't exist today, not even close. Also, there are some technical reasons why not all Bitcoin addresses are immediately vulnerable. But most importantly, Bitcoin's code isn't written in stone. The network can be upgraded to use new, quantum-resistant cryptography. The real question isn't whether it's technically possible. It is. The real question is whether millions of users all over the world can agree on how and when to do it. It's a huge governance challenge.
And that really leaves us with this final thought. When you step back, Bitcoin was designed from the ground up to survive. It has weathered market crashes that would have killed any normal company. It has routed around bans from superpowers. It has survived bitter internal civil wars over its own code. But with the very real, looming threat of quantum computing, you have to ask, for a system that is, at its very core, just a set of cryptographic rules, is its greatest, most existential test still ahead?